LeetCode Problem 211, Design, Add, and Search Words Data Structure. So this problem wants us to design a data structure that can add word and search for word easily. So we are looking at a try here, where because the search word will be very easy to do in a try. And the one thing we need to note is that the word may contain dot, the word we're searching for, and where the dot is like a wildcard, right? So for example, if a word like bad was added, then a dot ad, this dot can be a wildcard, right? It can be B, it can be A, it can be C, right? But for this case, since this will be a B, and since BAD was found, then this will return true, something like that. So that's what a dot means, which of course comes with its problem, but overall this is a pretty straightforward problem. So the first thing we need to have is a try node. So this try node will have 26 children, and it will has a boolean, and this boolean is to basically tell that this node is the end of a string. I clarify that more later on, but just know that when we construct this try node, all of the child will be set to null and the end will be set to false, right? See, when I construct the word dictionary as well, our root will be a new try node, right? So it will look something like this, where we have our root node. This is just a placeholder, and when we want to add word, let's say we want to add bad, right, bad. So what we do is we create a b, right? So if here you can see I am iterating through every character in the word. For this instance, it's bad, a. So we start with b, and I get the index, which is the character minus a. This will give us the index, and if the index is null, I'll just create a new try node. And in this case, since it was null, now that I've created one new try node, then my node will become b. So at b, this try node, I'll now try and look for a, but in this case, since b has no a nodes yet, so I'll just create more a, go into a, and create our last d. Okay, so right now our try looks like this. Our try looks like this. And if you want to add another word, let's say dad, that is as simple as just having another d here, a, and then d, right? All these words can be added like this. Okay, let's say if we want to add another character that starts with b, let's say we're adding book, for example. So we can reuse this b, since this b is at the same level, and we branch off to o, k. Okay, one thing to note that if you see here, we are marking the end of the word as the end as true. So just now this word will be marked as true, this will be marked as the end as well, this will be marked as the end as well. Okay, so that's about adding characters. So let's talk about finding characters. So the way I find character is to do it recursively, but let me explain how to do it in the iterative method if the dot were not present. So let's say I'm looking for bad again, right? So what I do is I start from the first level, I see whether or not there's a b. In this case there is, so I continue on to the next character, which is a. I see whether the b has child a. It's not now, okay, good. So we go here, and once that is done, I go to the last character, which is d over here. And when I reach d, since the string has ended, I will return whether or not this is the end node, right? This node is marked as the end, right? Okay, so in this case, since it is, so that means bad is found. But let's say if BAT, right? In this case, since T was, there's no T here, right? There's no T, so this will return false. Let's go another one. Let's say we are searching for BA only, right? We're looking for BA. So again, you start from B, you go to A,
And now we return whether or not this is marked. And since this is not marked, so BA does not exist, right? Remember that we added BAD, bad, but we did not add BA. If we were to add BA, so we can just reuse B here, go down, reuse A again, and then what we can do is we can just mark this A as the end of the node, right? Okay. Alright, hopefully that's enough. So let's talk about what happens if we run into a dot node, right? So when we have a dot, right? So something like dot AD. Okay, let's go something harder, right? Let's go with B dot dot. Okay, so the first character we know is B. Okay, then the next character, which is a dot. So what we do is we have to iterate through all of the nodes, all of the child B has that are not null, and then if there is a valid node, in this case A is a valid node, so we go to A, right? When we go to A, then we go to the next character, which is a dot as well. So what we do is we iterate through all the nodes all the child nodes that A has. But in this case, since there's only a D here, so what happens is we just return whether or not this is the end of a string, which in this case it is. That means B dot dot will return as true. Okay, hopefully that clarifies how my approach is. So let's talk about the code. Okay, so here in the add word, I think I showed this before. So I get the index. If it is null, I'll just create a new try node inside at that index. Otherwise, or not otherwise, then after that the node will be replaced with the child. That's how I recurse and create new nodes. Okay, and then when the for loop ends, this is very crucial. When the for loop ends, it means that the word is finished, so we mark the end of the node as true. In this case, BAD, the end of the node will be D here. Okay, now let's talk about the search node, which is more complicated. So I've replaced the search with another function called search node, right? The search node. So what this search node will take is the word, the index of the word we are looking at, and the try node. Right? This is the node where we are going to start a recursion, right? So if the node is null, okay, let's say we have added these words, right? Bad and book, and let's say if the word was something like this, right? Let's say the word was B dot let's say OK, O dot, okay lah, right? So at the first glance, we already know that this is a confirm a book, but let's see how the algorithm works. So if the node is null, return false. In this case, it's not null since that we are starting at the placeholder node. This placeholder node is never null. If I is equals to the word length, okay, I in this case is 0 over here, and our root is currently empty, right? It's a placeholder. Okay, since it's not the end of the word length is 4, so we do not return anything. If the word is not a dot, right? If the current character is not a dot, since B is not a dot, then we recurse, right? We recurse with the same word. So I'll recurse like this. Our I now becomes I plus 1 is 1, and the node we are looking at is now B, right? Remember that this will give us B, the first character. B minus A will get 2 or 1. Yeah, I think we get 1 because A, B. Yeah. So right now our root is more like the node. Let's call it node instead. Okay, the node right now is B. Okay, where B? I think there's a restriction that says that the words are all lowercase. Yeah, but I'll just use a capital letter just
to make it more clearer, right? Okay, we recurse like this. Okay, so now we are looking at a dot, and since this is now a dot, so what do? This if statement doesn't trigger, or this if statement does not trigger, and we start iterating through all the alphabets available. So let us try with as I equals to 2, and then the thing we're trying now is a. And since there is a, it is not null. So let's continue. Node is not null, I is not equals to word length, and now we're looking at O, right? Since it is not a dot, so we are recursing through again to the word I plus 1 equals to 3, and we are looking at our node right now. This is crucial since there is no O, right? There's no O at A, there's only D, right? There's only D, there's no O. So what happens is this is technically null, and when this is null, it will return false. Okay, so when this returns false, we are back to where we were when index was at 2, and then we have to continue on in the for loop, search for B. Right, B, since there's no B, so we return false again. Eventually, we explore all of the nodes until we reach O. And when we reach O, when we search node, there is a node here, right? Reach O, there's a node here. So we recurse again, right? Because now we're looking at another O. So I equals to 3, node equals to O. Since I has not become the word length, nor is it null, and it is not a dot, so we recurse again, searching the node. So now I equals to 4. Our node is currently K. Remember that there's only we're looking at K here, so now node is now K. It's not null because it exists over here. What happens is, okay, first thing first, the node is not null, and I is now currently at words length, right? I is 4, the word length is 4, so we have to return whether or not this K is marked as the end of a string. And in this case, since it is circled over here, that means this K marks the end of the string. That means we have found the word, which was BOOK, right? The book. Okay. When this gets returned, everything falls back, everything recurses back, and eventually we will just return true, right? So this will just return true. That means we have found a word here, which is BOOK, book. Right. Hopefully my explanation was sufficient. That's all I have to show. Thanks.